Hello everyone and welcome to Who Created It and How. Today we're looking up, way up, to marvel at one of architecture's most breathtaking achievements, the dome. From ancient temples to modern stadiums, these colossal curved ceilings have captivated us for centuries. But have you ever stopped to wonder how on earth they were built? How did ancient engineers, without the help of modern cranes and computers, manage to construct these massive self-supporting structures? It's a story of incredible ingenuity, a little bit of physics, and a lot of brave workers. So stick around as we unravel the secrets behind the construction of the world's most magnificent domes. Let's start our journey in ancient Rome, home to one of the most iconic domes ever built, the Pantheon. Completed around 128 AD, its dome is still the world's largest unreinforced concrete dome nearly 2,000 years later. That's just mind-blowing. So how did they pull it off? The Roman genius lay in their materials and design. They invented a unique form of concrete, a mix of lime, volcanic ash called pozzolana, and water. This wasn't your average sidewalk concrete. It was lighter and incredibly durable. The real trick was how they used it. At the base of the dome, the concrete mix included heavy aggregates like travertine and terracotta tiles. As they built higher, they switched to lighter materials like porous tufa stone and even pumice, a volcanic rock so light it can float on water, right at the very top. This clever graduation of weight significantly reduced the stress on the structure. But what about the shape? The Pantheon's dome is a perfect hemisphere, and its construction required a massive temporary wooden framework, or centering. Imagine a huge, complex wooden skeleton built on the floor, rising up to support the dome as the concrete was poured layer by layer. This scaffolding had to be immensely strong to hold the weight of the wet concrete until it cured and became self-supporting. Once the concrete was set, the painstaking process of removing this wooden support began. I can only imagine the suspense the builders felt, hoping their calculations were correct and the massive structure wouldn't come crashing down. Another brilliant feature is the oculus, the famous opening at the top. It's not just for looks. It reduces the weight at the dome's weakest point, the apex, and allows light to flood the interior, creating that incredible, ethereal atmosphere. The Romans truly were masters of engineering. Now, let's fast forward over 1,000 years to Renaissance Florence and the magnificent dome of its cathedral, the Duomo, designed by Filippo Brunelleschi. This wasn't just another dome, it presented a whole new set of challenges. The opening it needed to cover was enormous, and the city officials had one major rule: no external buttresses, those supportive arches you see on Gothic cathedrals. Plus, there wasn't enough timber in all of Tuscany to build the traditional centering needed for a dome of this scale. It was a seemingly impossible task. For years, the massive hole in the cathedral's roof sat open to the elements. Enter Brunelleschi, a goldsmith and clockmaker, not a traditional architect. His solution was so radical that many thought he was mad. He proposed building not one, but two domes, an inner one and an outer one, nested together. This double shell design made the structure lighter and stronger. The inner shell was the main structural support, while the outer shell protected it from the weather and gave it its grand, imposing profile. But how would he build it without scaffolding from the ground? Brunelleschi's true genius was in the brickwork. He devised a self-supporting herringbone brick pattern. As the workers laid the bricks, they interlocked them in a way that prevented them from falling inward, even as the dome curved up. The structure essentially supported itself as it was being built, rising ring by ring. It was a revolutionary technique that allowed the dome to be constructed without that massive floor-based centering. Brunelleschi also had to invent new machines to get the job done. He designed a special ox-powered hoist with a revolutionary reversing gear system, which allowed heavy materials like sandstone beams to be lifted over 200 feet into the air and then moved horizontally with incredible precision. He even set up canteens with food and wine up on the dome to keep his workers from making the long, tiring trip down for their lunch breaks. He thought of everything. When the final stone was laid in 1436, it was a triumph of human intellect and perseverance. Brunelleschi's dome redefined what was possible in architecture and became the symbol of the Renaissance itself. Let's leap forward again to the 17th century and another iconic dome, St. Paul's Cathedral in London, designed by Sir Christopher Wren. After the Great Fire of London destroyed the old cathedral, Wren was tasked with creating a new masterpiece for the city's skyline. He was heavily influenced by both the Pantheon and St. Peter's Basilica in Rome, but he added his own unique English twist. Wren's design is a clever illusion. What you see from the outside is not the same structure you see from the inside. Like Brunelleschi, he used a multi-shell approach, but he took it a step further with 3 distinct layers. There's a relatively shallow inner dome that's aesthetically pleasing for visitors looking up from the cathedral floor. Then, hidden between the inner and outer layers is a structural marvel, a brick cone. This cone, reinforced with a massive iron chain around its base to counteract the outward thrust, is the true workhorse. It supports the weight of the elegant stone lantern that sits on top of the cathedral and also supports the outer dome. The outer dome, the one we see gracing the London skyline, is a relatively lightweight timber structure covered in lead. It's designed for maximum visual impact, from a distance, rising high above the surrounding buildings. So Wren essentially created 3 domes in one. An inner dome for interior beauty, a hidden brick cone for structural strength, and a grand outer dome for the external silhouette. This ingenious triple dome system allowed him to satisfy both the artistic and engineering requirements of the project. The great iron chain he installed was a crucial innovation, acting like a giant belt, cinching the base of the brick cone and preventing it from spreading apart. It's a testament to Wren's deep understanding of structural forces. Of course, the story of domes doesn't end there. In the 20th and 21st centuries, new materials and technologies have pushed the boundaries even further. Take the geodesic dome, popularized by architect and inventor Buckminster Fuller. These domes aren't built with massive stone or concrete, but with a complex network of interlocking triangles, usually made of lightweight steel or aluminum struts. The genius of the geodesic design is that it distributes stress across the entire structure, making it incredibly strong and stable for its weight. You can create enormous clear span spaces without any internal columns or supports. Think of the iconic spaceship Earth at Epcot in Disney World. That's a geodesic sphere. These domes can be assembled relatively quickly from prefabricated parts, a far cry from the decades it took to build the Duomo. And today, we have domes made from even more advanced materials. There are ETFE domes made from a type of high-strength plastic foil, like the one at the Eden Project in Cornwall, England. These biodomes are made of huge, inflated pillows of transparent plastic, creating massive climate-controlled greenhouses. The material is incredibly light, just 1% of the weight of glass, and it allows sunlight to pour in, creating a perfect environment for thousands of plant species. Engineers used powerful computer software to model the complex forces of wind and weather, ensuring these lightweight structures are safe and durable. From Roman concrete and Renaissance brickwork to steel triangles and inflatable plastic, the evolution of the dome is a fascinating story of human creativity. It shows our relentless desire to build bigger, higher, and more beautifully, constantly innovating to turn ambitious visions into reality. So the next time you stand beneath a grand dome, take a moment to look up and appreciate the incredible journey of its creation. Think of the Roman engineers mixing volcanic ash into their concrete, Brunelleschi's masons laying bricks in a complex herringbone pattern, Wren's team hoisting a giant iron chain into place, or modern builders snapping together the triangles of a geodesic dome. Each one is a monument to problem solving, a masterpiece of art and science combined. They remind us that with enough ingenuity and determination, there's no limit to what we can create. Thanks for joining us on Who Created It and How. We hope you enjoyed this look into the amazing world of dome construction. If you found this video interesting, please give it a thumbs up. And don't forget to subscribe to our channel for more deep dives into the history of how things are made. Let us know in the comments which architectural marvel you'd like us to explore next. See you in the next video.